Hello everyone. In this session we are going to talk about two-dimensional motion. So before we talk about two-dimensional motion, let's quickly recap something about one-dimensional motion. So what is one-dimensional motion? As you can recall, the one-dimensional motion is the motion which is restricted in a straight line. For example, if a car is moving on a straight line road, then we will say that car is performing one-dimensional motion. Or for example, if I drop a stone from a top of a tower, okay, so then this stone will come down in a straight path. Okay, this is a linear path and that is one-dimensional motion. Okay, but now what we are going to do is we are going to talk about the motion which is restricted in a two-dimensional plane. Okay, in a 2D plane, right? For example, if you have heard about this game called the snooker, okay, or they will call it as billiard ball game, something like that, okay, where what happens, there is a board like this, okay, this is the billiard board, and on this board there are balls like this. These are billiard balls, okay, so their motion is restricted only on this board. Okay, so they are not going outside this board. Okay, and they are not moving up or down. They will not move in the upward direction or downward direction. Of course, down they cannot move because board is there, right? So only if I hit it hard enough, only if I hit this ball hard enough, then only it can jump and cross, get away from the board, right? But we are not going to take into account that thing. Okay, so here the motion of these balls is restricted only in two dimensions, right? So in this case we require two coordinates to locate a ball at any time in a billiard board, okay, on a billiard board. For example, if I take this as my origin, then I will have to, suppose if I have to find out the position of this ball, then I can find out the position by measuring its length horizontally and vertically like this. So the vertical length is y1 and the horizontal length is x1 from the left end. Then I will say that its coordinate is x1, y1. So this information of x1 and y1 is enough to find out the location of that billiard ball, right? So let's make this concept into the mathematical form. Okay, so here what I am going to do is I am going to take a two-dimensional coordinate system. Okay, so the horizontal coordinate is x, axis is x, and the vertical axis is y. Now in this case, let's draw our billiard ball over here like this. Okay, this is a billiard ball, suppose, or any particle. Okay, let's assume it is a particle. Then its position is given by this vector which starts from the origin. Let's say this is the origin. Okay, this is the origin and this is the position vector. Let's say this is r1 bar. Okay, so this is initial position, you can say. So the coordinates of these green color particles are x1 and y1. Okay, so now this is r1 bar, which is called as position vector. What does it do? It gives you the position of that green color ball or a particle. So this is a position vector r1 bar. Okay, now let's assume that this ball follows a certain path like this, okay, and ends up being here. Okay, so let me draw it properly over here. So it ends up being here, and now let's say this coordinate, these coordinates are x2, y2. Okay, so these are the final coordinates. So the position vector now will be like this. So this will give r2 bar. Okay, so this is also a position vector, but this is a final position vector. Okay, as opposed to the initial position vector that we have shown earlier to be r1 bar. So this is initial, okay, initial. This is final. Now what happens over here? This difference in position can be subtracted. So can be not subtracted, sorry. The difference in these two positions can be given by a displacement vector. And what we do, displacement means, displacement is the shortest path from initial position to final position, which is a straight line. Okay, so let me use a blue color here to show that. So this is a straight path which will show you the displacement. Okay, so now what is the displacement vector over here? So displacement vector is defined as, displacement vector, I'm giving a huge arrow on this because this is a vector. So it is given as R2 bar minus R1 bar. So this is the displacement vector, correct? So now if I write this in terms of component form, okay, so you know R1 bar can be written as x1 I cap plus y1 j cap, and R2 bar can be written as x2 I cap plus y2 j cap. Now if I do R2 bar minus R1 bar, then what I will get? The displacement vector, let's say it is S bar. So displacement vector S bar is x2 minus x1 I cap plus y2 minus y1 j cap. So this is the displacement vector. So this is the displacement, right? And what about the magnitude of the displacement? The magnitude will be simply x2 minus x1 square plus y2 minus y1 whole square and square root of that. So let's see what is the magnitude. Magnitude of the displacement is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this is the distance formula, right? Now what we have to do is consider one example. For example, a person is there, okay, a person is initially at position 1 and 2, okay, initially he is at 1 and 2, and the final position is, let's say, 4 and 7. Okay, now if I ask you what is the displacement vector for this particular situation, then what you will do? You will name this as x1 y1 and you will name this as x2 y2. Now we can see that S bar, that is the displacement vector, as you can see here, is this x2 minus x1 I cap plus y2 minus y1 j cap. So here what I will do, I will substitute it here, x2 minus x1 I cap plus y2 minus y1 j cap. So if I substitute it, y2 is 7, sorry, x2 is 4 and x1 is 1. So 4 minus 1 I cap plus y2 is 7 here and y1 is 2 here. So 7 minus 2 j cap. So which is equal to 3 I cap plus 5 j cap. Now what if I ask you what is the magnitude of the displacement vector? Then the magnitude of the displacement vector is simply given by square root of 3 square plus 5 square. This is the magnitude of this vector, by the way, right? So this is 9 plus 25. So 9 plus 25 is 34. Okay, so 34 units, square root of 34 units is the magnitude of the displacement vector.